Okay, we're back at it again, live. Now, this time in live. So today, you already memorized your soluble and insoluble salts. If you don't know, just take a picture of the table I gave you and just put it on the next tab or something so you get like a clearer picture of what's going on. So you have a soluble and you have also insoluble salts. So just now you learn how to distinguish between male and female, okay? Now you gotta know their characters. You gotta know like what kind of characters fits what kind of people. So in our surrounding society, right, we have male, female, and then those in-betweens, And then those in-betweens, right, there are flags. Like their flags are very colorful, rainbow color, right? So basically, like us, like the elements itself, Chemistry teach you a lot about life as well. So, you in class, your teacher probably say all transition matter has colors. Exactly, man. So that means exactly like our country, everybody who enter transition, right, their flag is what? Rainbow, colorful, right? So that's all the support, the half that kind of thing. Yeah, they are all very colorful people. So same goes to metals and all. By the way, no offense to all the whatever in betweens. So all the transition metal all have colors, because they're a bit special. So first of all, you gotta know that the colors that you have in your textbook and in real life you see, sometimes the color may be differ from each other. So first of all, why do transition metal actually give off colors? Okay. Colors, we perceive colors, right, because of the light reflected out of the atom. So usually, when let's say for example you see plant is green color, okay, just for an example, so you can understand why plant is green color. So plant is green, right, because the plant absorbs every single light colors. Colors got like rainbow color, but there's so many waves. The plant will absorb all except green. This green wavelength that appears to the color green, they only reject that light, so they reflect that light back out, which goes to our eye, and that's why you see the plant is green color. So same goes to transition metal. So their color also is dependent on their concentration and what kind of compound they mix with, and also it depends on what kind of light they reflect out. So let's say for example we give a transition metal, let's just say Fe2 plus. Usually Fe2 plus is gonna appear as light green, a very faint light green when you put it in a solution. But it depends on what kind of salt you mix with, So let's say for example, in reality, if you make Fe and you mix with Cl, you get like a not just light green, you may get like dark green. Sometimes you may get another different kind of like orange, that kind of color, or yellow. You don't know one, because it depends on the purity of your substance as well. So first of all these colors you learn as a transition metal, they may not be fixed or permanent. It dependent on what kind of container you put it in, the place you're in, the light that you shine to the thing to see your color. Because colors is one of the things that can be different for different people. Some people see blue, some people see green. Depends. So usually the things that you learn in the textbook, based, they are all just like, really watered down. It's like, sodium, potassium, calcium, magnesium, yeah, they say it's white color. Okay, let's just for example, these four, when they're in like the aqueous state or solid state, yeah, it's white color. But then, if you do the real test, there's actually different concentration of white depending on what kind of compound they are, So not necessarily they're all gonna look the same. They may look a bit different one. Their material a bit different one. You can know that this is a magnesium or a calcium one just by looking at it. Okay. So out of the way, so we're gonna just do it for 6 of tests. So for tests, you only gotta know that the few very, very colors. So what you're gonna learn is not gonna be 100% accurate, but it's gonna be useful just for your tests. So it's only for your test only. So we're gonna learn about transition metals. So like I said, the one that is a bit half one, yeah, they're a bit colorful. So it's Fe2 plus, Fe3 plus, CO2 plus, Zn2 plus, MnO4, CrO4, CrO7. So these are all transition metals lah. You regard them as a transition metal because they exist between group 3 and 12. So all these metals, they have color. And why they have color? Because they reflect they reflect back that light out when they go to the atom. So let's just say for example, this is an atom right here. Okay. So usually you have light rays entering it. Okay, light rays entering it. Okay. Sometimes some of the light rays is being absorbed. So let's say for example, if this particular ray, let's just say I draw 2 more white color lah. Okay, and the white color ray get absorbed. Okay, like this is usually appear as one whole lah, like the package of the light lah. Light exists in one package. Okay, So when they enter the light, okay, they masuk the light lah. Okay, they masuk the light. Okay, they masuk. Okay, this is a very bad drawing. And then let's say for example, the atom absorbs all the light, but it reflects only the white light out. So you will usually see that, forgive me lah, as long as you understand. So you will usually will see the white light. They don't absorb the white light, so the white light will reflect it out, and that's what we see. So that's what we usually see on most of our salt, on our like potassium chloride or like NaCl, that kind of thing. They appear a bit white color. Okay, so that's the light they reflect out, they reject. The rest they absorb. Okay, why they absorb? Because that one you will learn in like maybe in A levels. So you learn about, let's say, the energy thing. Why would they absorb it? It's actually something to do with your very molecular chemistry, that kind of thing. It also do with like those physics. So if you guys are interested in it and you want to study more about it, well, just continue on to pursue your science. They'll teach you. Apparently, if you really want to look it up, you can actually also look in like YouTube and all. They will really explain to you lah, like how is it all. So transition matter, they usually give out colors. So today we're gonna like talk about which one will usually give you the color, which one is the most famous one. So I'll go down and then I'll drag, I'll crop this out. So I'll select a rectangular selection. I'll take this out. So the rest of course is just white color. Okay, so it's just gonna be white. So let me take this down here, Fe2 plus. So this one, let me just make it black. Make it black back. Okay. Okay. So now, usually Fe2 plus, the exam kind of standard, right? Fe2 plus will be green color. So let's just draw Fe2 plus in green. It will be like a light green, that kind of thing. Fe2 plus. Fe2 plus. It's usually green. It's usually green. And then Fe3 plus is not green. It's gonna be about orange color. You can you know iron rust, right? So Fe3 plus is the rust type of color usually. So it's also related to, that's why your blood is red color, you know, because your blood contains iron as well. So next you also have copper, which is Cu2 plus. Okay, copper, just remember it's Cu2 plus. Then you have also Zn. Zn is zinc. Zinc is usually seen on rooftops. Okay, on rooftop, those metals. So zinc is usually white color. Okay, it's a kind of metal. So zinc is quite easy to remember because you understand zinc. Zinc is like those shiny layer you usually see in like rooftops, and sometimes you see like in the construction there, you see those crooked like that kind of rooftops. Yeah, that is made of zinc usually, and that is usually, if it's in a cation form, it usually doesn't have a color in it. So manganate. Manganate is usually is a famous thing you use for tests. So it's gonna be purple. So please, if you remember it, you try your best to remember, because this 100% comes out in exams. It's either in redox reaction or salts, because manganate and dichromium or dichromate, that kind of thing, they usually come out as a oxidizing or reducing agent. So regardless of them, you have to memorize them. So definitely chromate. Chromate is yellow. Okay, then if it's then they will usually like oxidize, that kind of thing. Then they'll give you dichromate, that kind of stuff. So, and then you have also orange. Back again, it should give you Cr 207 2 minus. Okay, now usually this tree is something that you will know it by heart lah, because you're gonna do all the exercise that's gonna be related to this usually lah. Usually the one that usually confuse the people the most is usually the colors of dichromate and chromate and iron 2 plus and iron 3 plus. Usually copper and zinc people always know it's white color, but not for the chromate and dichromate though, because chromate and dichromate is like orange and yellow, and same as like iron 3 plus is also orange. So this is the part, is the more confusing part, but no can do, man. You gotta memorize that shit. It's just like personality. So definitely all these ions, iron thing, they exist in solid and also in aqueous. Usually you regard them as the same color. Let's say for example FeCl, if the exam come out, it's gonna, when it's in aqueous, it's gonna be greenish, you know, greenish light green color. They'll accept it as answer. And I say FeCl, if they are soluble in aqueous, okay, then you're gonna get as well as also orangey kind of color, that kind of thing. So if we take a look back, like where your soluble and insoluble actually apply to this is when, let's say for example, you have a question that relates with this kind of salt. So that's where your soluble and insoluble salts knowledge comes to use, you know. Okay, now I'm going to tell you how it comes to use. So let's just say for an example, let me find back the page of notes. Hold on, I'll cut this part out. Okay, salts. Okay, let's just say for example, like all sodium salts are soluble in water. Okay, let's just say all chloride salts are soluble in water except PbSO4. Okay, now this is like a question that you should remember. Like all chlorides are soluble except PbCl2. Okay, so usually we have this kind of question. Let's say PbCl2. So let's say for example here they write cation and ion salts Pb2 plus. So let's say for example it mixed with Cl, so you get a PbCl2. So when you mix it with water, should it be soluble or should it be aqueous? So sometimes when they will test you this, right, and then they'll ask you, is it insoluble or soluble in water, and what color is it? So this is where your soluble, insoluble knowledge comes into play. So this is where you apply both together to distinct the result of the salt thing. So they could also ask you in many different kind of questions. Let's say maybe they say like if iron plus chloride, they mix in water, and then is it soluble, insoluble, and what color is it? So this could be like a 2-mark question. And then if you memorize all these things, those marks are easy, and usually if you have all this knowledge, the following one gets even easier. So in salts, you now figure it by now. You gotta know it layer by layer by layer by layer. You know, first you have to know which is soluble, which is insoluble. Then you have to know the color, and then that would actually tell you the answer usually in the end. So moving on is also the cation, the anion salts as well. So let's say you have a chloride, SO4 2-, NO3-, CO3 2-. So these are usually colorless, like when I say white color, like the one that is I left over here, these are all white color. So the only exception is that when they are mixed with a transition metal. So let's say for example Fe2+, you mix with a CO3 2- carbonate. So you usually check like is carbonate, like, see you right here, all carbonates are insoluble in water except NH4, Na2, K2. So you know that carbonates are insoluble. So you know that when it mixed with a manganate salt is going to be insoluble. And as well, it's going to leave a precipitate. So it's going to have a purple precipitate. If it's no, it's not purple precipitate. Let's say for example, it mixed with a copper carbonate. What color is you're going to get a blue precipitate, something like that. That's an example. Okay. So that is it actually for today. Today you're going to learn about colors. So you got to take it slow, step by step. About carbonate, about all the transition metal, their coloring and stuff like that. So hopefully this will help you guys to understand a bit more. But basically there's not much usually you have to just to memorize it. Let's say for example another one is like potassium manganate. The very famous one, the potassium manganate, is just KMnO4. KMnO4, right, when you put in water, right, you know potassium, all potassiums are soluble. So it's gonna give you what? Purple color. Very simple. And let's just say Zn2+. Zn2+ mixed with SO4 2-. So you know that all sulfate is soluble, and zinc 2+ is not under categorized as the soluble salts part. So ZnSO4 is going to be soluble in water, and it's going to have colorless state. It's going to be colorless, ZnSO4. So we can always cross check our answer. Like just now I asked, I was using what now? I was using Cu2+ and SO4 2-. Okay, we can cross check. So Cu2+, SO4 2-. So let's just say copper sulfate. Copper sulfate, you see, is blue. Anything relate or anything with the transition metal, right, is gonna be blue. Let's just say solution blue, because all sulfate is soluble in water, except a certain few lah, which is PbSO4, BaSO4, CaSO4. So let's just say copper carbonate. What color is it? Copper carbonate. So copper carbonate, you see, it's not actually blue, right? It's another kind of color, right? It's about greenish, that kind of thing. So that's why I say, like, it's not exactly you'll get the color you want. A copper carbonate, let's just say solubility. Let's just say, is it soluble? Oh no, you cannot. It's not soluble in water, I think. Precipitate. Let's just see. Precipitate. Copper carbonate. See? So all carbonate are insoluble water. Yeah. So technically, copper carbonate is insoluble. So you can usually use your wiki to cross-check your answers very easily, because that's what I do as well. Because it's impossible for you to memorize everything. Seriously, it's quite impossible. So let me see, copper sulfate, copper sulfate in water. So you can see the images. So apparently it doesn't. It doesn't actually. It precipitates. Okay, so yeah, it precipitates. So definitely, like what the paper says is correct lah. All carbonates are insoluble. So it mixed with copper, it's gonna give you this color. So usually you won't know the actual color is what until you do the experiment yourself. Usually one way is that you can know the color agak-agak how is that if you do the experiment in your school, it's about related to carbonate one, like calcium carbonate. You get the milky kind of color, right? So you see that milky color mixed with this blue, you get that kind of like a bluish milky kind of thing. So in future, you will do more of these experiments lah. If you you pay more money for colleges, yeah, they will help you perform these experiments because some of the materials here are quite expensive. So that is it about colors today. So I hope I'm able to help you to distinguish about colors and all. So yeah, that's about it, guys. Thank you for watching, and see you guys on the next one.